Oversensing is when a pacemaker detects signals other than the depolarization of the relevant chamber. This can cause the pacemaker to withhold pacing. I'm just going to explain this in more detail. So, first let's have a look at some oversensing of artifact. If we look at this egram, we can see 4 large deflections, and these are your genuine depolarizations of the ventricle. However, we can also see some artifact. We've got 2 examples here. We've got some muscular artifact and some electrical artifact. And in each of the scenarios, the artifact is being registered by the pacemaker as ventricular activity, when of course it isn't. It is just noise, it's just interference being mistaken for ventricular activity by the pacemaker. How can this oversensing withhold pacing? Well, let's have a look. Here we have a ventricular channel. Now, this looks like atrial fibrillation, but it is not. We are only looking at a ventricular egram. On the egram, we have 1, 2, 3, 4, 5, 6 genuine QRS complexes. However, the pacemaker is detecting some artifact as genuine ventricular events. We can see one here, 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 and here. So fortunately, in this example, it hasn't caused too many issues, but this is because the patient has a good underlying rhythm. What happens if the patient doesn't? Well, let's look at the example below. We have 1, 2 genuine QRS complexes. Now, unfortunately, the pacemaker is also picking up this artifact and thinking it is a ventricular depolarization. We have one here, 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 and another 3 here. So, this has confused the pacemaker into thinking that the ventricles are contracting and the heart is beating. We can see that this is actually artifact. This patient has suffered a significant pause, but because of this oversensing, the pacemaker has got confused and has withheld its pacing therapy, causing this patient to feel very unwell or even faint. The easiest way for us to resolve the oversensing of artifact is to make the ventricular channel less sensitive. Here we have made the ventricular channel less sensitive, and you can see that we are no longer oversensing these events. As a result, the pacemaker would have kicked in and paced regularly, stopping this person from fainting. I want to introduce you to some other types of oversensing. Now, in the ventricular channel, we can often oversense T waves. Let me explain what I mean. Here we have a pacing output pulse triggering depolarization of the ventricles. However, we know that this tissue will eventually repolarize, and in doing so will give us a T wave. Now in this example, we can see that the T wave is also detected in the ventricular channel. This can cause problems with a number of the pacemaker's timing cycles. We really need to address this problem. We remove T-wave oversensing by decreasing the sensitivity of the ventricular channel, and you can see here that the pacemaker is no longer seeing these T-waves and is no longer registering them. Another form of oversensing we can get on the ventricular channel is crosstalk. Let's just have a look at what is happening. Crosstalk is where the atrial output pulse that is there to trigger a depolarization of the atria is actually large enough that it gets detected on the ventricular channel. And here we can see the output pulse has been registered as a V-sensed event. This has happened here. We can see this all the way through this electrogram. We have crosstalk. Now crosstalk can be catastrophic. If this person had no ventricular rhythm, every time that the pacemaker sensed this atrial output pulse in the ventricle channel, it would just assume that the ventricles had depolarized and withhold pacing. So if this patient had no ventricular rhythm, the pacemaker would be satisfied by these atrial output pulses and this person could die. Crosstalk could be a really serious problem. Luckily, many of the pacemakers now have built-in algorithms that protect against this. But essentially, if you do see crosstalk, you can resolve this again by making the ventricular channel less sensitive. Now, the final example of oversensing I want to give you is on the atrial channel and demonstrated on this atrial egram. Let's have a look what is happening. Well, the atria is depolarizing and is seen here as this huge P wave and is marked, quite rightly, as an asensed event on the atrial egram. Now this signal moves through the AV node, causing the ventricles to depolarize, which is great. However, the ventricles are very large, they have a lot of tissue, and this depolarization can actually be detected on the atrial channel. So we can see here that the atria are depolarizing and then the ventricles are depolarizing in turn. Unfortunately, that too is being detected on the atrial egram. We don't want that. Again, to resolve the situation, we can make the atrial channel less sensitive. And here we can see we are not registering the far-field R waves. So, your takeaway message? Most types of oversensing can be resolved by making the pacemaker less sensitive.